For decades, this field has relied on deterministic models and human expertise. But the world is changing with the advent of artificial intelligence. AI involves developing algorithms that enable computers to learn from data, make predictions, and take actions to achieve specific goals. The integration of AI into analytics is a paradigm shift, moving beyond traditional optimization techniques. Agentic AI, a form of AI that empowers machines to act autonomously, is already transforming industries across the globe. Agentic AI empowers machines to act independently and make decisions that impact the real world. An agent perceives its environment, reasons about its goals, and takes actions to achieve those goals. Unlike traditional AI, which might predict congestion, Agentic AI could dynamically adjust traffic lights or control autonomous vehicles in real time. This autonomy sets Agentic AI apart, enabling it to make decisions without constant human supervision. Agentic AI represents a fundamental shift from traditional AI models. Traditional AI excels at specific tasks, like predicting customer churn or recommending products. Agentic AI handles dynamic environments, adapts to changing conditions, and makes autonomous decisions. For example, in logistics, Agentic AI can monitor traffic, weather, and driver availability in real time, adjusting routes dynamically. This level of autonomy and adaptability was previously unimaginable. Agentic AI is transforming analytics by handling complexity that overwhelms traditional methods. These systems process vast amounts of data, identify patterns, and make decisions at scale, enhancing efficiency and productivity. By automating tasks and optimizing processes, Agentic AI frees up human workers for strategic and creative endeavors. In healthcare, for example, Agentic AI could personalize treatment plans and optimize resource allocation in hospitals. The applications of Agentic AI are vast, cutting across industries and revolutionizing business operations. In logistics, Agentic AI optimizes delivery routes, manages inventory, and predicts disruptions. The financial industry uses Agentic AI for automated trading risk management and fraud detection. In defense, autonomous drones conduct surveillance and engage in combat, reducing risk to human soldiers. As technology evolves, more innovative applications will emerge, transforming industries and shaping the future of work. AI is transforming analytics by augmenting traditional techniques, unlocking new levels of efficiency and insights. AI analyzes massive data sets, identifies hidden patterns, and generates predictive models for real-time decision-making. This capability is valuable in areas like demand forecasting, risk assessment, and fraud detection. AI-driven processes enhance productivity, reduce costs, and accelerate innovation. Agentic AI offers a paradigm shift in optimization by embracing decentralization, adaptability, and learning. Instead of centralized control, Agentic AI empowers individual agents to make autonomous decisions based on local information. This approach allows for greater flexibility and robustness in dynamic environments. Examples include autonomous vehicles navigating cities and robots collaborating in warehouses. Agentic AI moves beyond classical optimization, tackling complex problems dynamically. Multi-agent systems, MAS, are at the heart of Agentic AI, consisting of autonomous agents interacting to achieve goals. These agents can be software programs, robots, vehicles, or human decision-makers. MAS interactions include cooperation, competition, negotiation, and coordination. Effective interaction and coordination among agents solve complex problems. This shift to decentralized, agent-based systems models real-world environments more realistically and flexibly. Decentralized decision-making. The power of collaboration. Decentralized decision-making is a cornerstone of Agentic AI. enabling systems to operate effectively in environments where centralized control is impractical or impossible. In such systems, each agent makes decisions based on its local information and interactions with its neighbors, without relying on a central authority to dictate its every move. This approach offers several advantages. First, it enhances robustness. If one agent fails or its information becomes unreliable, other agents can compensate, ensuring the system as a whole remains functional. This is crucial in dynamic and unpredictable environments where centralized systems are vulnerable to single points of failure. Second, decentralized decision-making promotes scalability. As systems grow larger and more complex, centralized control becomes increasingly challenging. By distributing decision-making authority among multiple agents, we can handle larger problems and adapt more easily to changing conditions. Furthermore, this approach often leads to more efficient solutions. In many cases, agents can find locally optimal solutions that, when combined, result in a globally optimal outcome. This is particularly true in problems with spatial or temporal dependencies, where local information is crucial for making informed decisions. Supply chain management, agile, and adaptive systems. Supply chains, with their intricate networks of suppliers, manufacturers, distributors, and retailers, are ripe for optimization using agentic AI. Traditional supply chain management systems often struggle to cope with the inherent complexities and uncertainties of these networks. Agentic AI offers a more agile and adaptive approach, enabling supply chains to respond more effectively to disruptions, optimize inventory levels, and improve overall efficiency. Imagine a supply chain where each entity, from individual trucks to warehouses and manufacturing plants, operates as an autonomous agent. These agents can communicate with each other, share information about inventory levels and demand forecasts, and make decentralized decisions about production schedules, transportation routes, and inventory management. This level of autonomy and coordination allows supply chains to become more resilient to disruptions. For example, if a supplier experiences a delay, other agents in the network can adjust their plans accordingly, minimizing the impact on the overall supply chain. This adaptability is crucial in today's volatile global marketplace, where disruptions can arise from various factors, from natural disasters to geopolitical events. Autonomous negotiations, striking the best deals. Negotiation is a fundamental aspect of many business interactions, from securing contracts and resolving disputes to allocating resources and forming partnerships. Agentic AI is poised to revolutionize this domain by enabling autonomous agents to negotiate on behalf of humans, striking deals that maximize their interests while adhering to predefined constraints and objectives. Imagine a world where AI agents negotiate the terms of complex business contracts, haggling over prices, delivery schedules, and liability clauses, all while considering legal precedents, market dynamics, and the strategic goals of their human counterparts. These agents can analyze vast amounts of data, identify patterns, and predict the outcomes of different negotiation strategies, enabling them to secure favorable outcomes for their clients. In the realm of e-commerce, AI-powered shopping assistants could negotiate with online retailers on behalf of consumers, finding the best deals on products and services while taking into account factors like price, shipping costs, and return policies. This could empower consumers and level the playing field in online marketplaces. Predictive analytics, anticipating the future. Predictive analytics plays a crucial role in optimizing operations across various industries. By analyzing historical data and identifying patterns, predictive models can anticipate future trends, enabling businesses to make more informed decisions about resource allocation, pricing strategies, and risk management. Agentic AI is taking predictive analytics to the next level, enabling systems to not only predict the future but also adapt and respond to changing conditions in real time. Imagine a financial trading system powered by agentic AI. These systems can analyze market data, identify patterns, and predict future price movements with remarkable accuracy, but they can go beyond simple predictions. These agents can execute trades autonomously, adjusting their strategies in real time based on market fluctuations and news events. In healthcare, Agentic AI can be used to develop personalized treatment plans for patients. By analyzing a patient's medical history, genetic information, and lifestyle factors, these systems can predict the likelihood of certain health outcomes and recommend interventions to mitigate risks and improve overall well-being. Reinforcement learning training agents through trial and error. Reinforcement learning, or RL, is a powerful technique for training agents to make optimal decisions in complex, dynamic environments. Inspired by how humans and animals learn through trial and error, RL algorithms enable agents to learn from their experiences and improve their performance over time. In RL, an agent interacts with its environment by taking actions and receiving feedback in the form of rewards or penalties. The agent's goal is to learn a policy, a mapping from states to actions, that maximizes its cumulative reward over time. The agent explores its environment, trying different actions and observing the consequences, gradually refining its policy to achieve optimal behavior. This approach has proven highly effective in various domains, from robotics and game playing to resource management and personalized recommendations. For example, RL has been used to train robots to perform complex tasks, such as grasping objects and navigating obstacles without explicit programming. Heuristic search, navigating complex decision spaces. Many optimization problems involve searching through vast and complex decision spaces to find the best possible solution. Heuristic search algorithms provide a way to navigate these spaces efficiently, using rules of thumb and problem-specific knowledge to guide the search process towards promising solutions. These algorithms employ heuristics, or educated guesses, to evaluate the potential of different search paths and prioritize those that are more likely to lead to optimal or near-optimal solutions. This allows them to find good solutions within a reasonable amount of time, even when the search space is too large to explore exhaustively. Heuristic search algorithms are widely used in various applications, from routing and scheduling problems to game playing and protein folding. For example, in the traveling salesman problem, where the goal is to find the shortest route that visits all cities exactly once, heuristic search algorithms can be used to find near-optimal solutions efficiently. Dynamic programming, breaking down problems into manageable subproblems. Dynamic programming is a powerful optimization technique that breaks down complex problems into smaller, overlapping subproblems and solves each subproblem only once, storing the solutions in a table for later use. This approach avoids redundant computations and enables efficient solutions to problems that would otherwise be intractable. The key idea behind dynamic programming is to exploit the overlapping substructure of many optimization problems. By breaking down the original problem into smaller, self-contained subproblems, we can solve each subproblem independently, and then combine the solutions to obtain the optimal solution to the original problem. Dynamic programming is widely used in various fields, including computer science, analytics, and economics. For example, it is used in sequence alignment algorithms in bioinformatics, shortest path algorithms in graph theory, and optimal control problems in engineering. The autonomy of agentic AI presents unique challenges that require careful consideration. Unintended consequences and unpredictable outcomes are primary concerns. As systems become complex, predicting behavior in every scenario is difficult. Anomalies or minor decisions can lead to harmful outcomes. Autonomous decision-making raises questions about accountability and liability. Who bears responsibility for undesirable outcomes? Developers, users, or the AI itself? These questions have far-reaching legal and ethical implications. Addressing these challenges requires ethical frameworks and robust governance. The goal is to harness AI's power responsibly for humanity's benefit. The allure of agentic AI lies in its promise of autonomy, machines making decisions without constant human oversight. This autonomy enables efficient operation in complex environments, surpassing human capabilities. However, too much autonomy presents a paradox. How much control to relinquish? Striking the right balance between innovation and control is crucial. Excessive control stifles innovation, while too much autonomy can be harmful. Designing AI with clear objectives aligned with human values is key. Human oversight at critical junctures provides a safety net. As agentic AI systems become increasingly integrated into critical infrastructure and decision-making processes, ensuring their security becomes paramount. These systems, with their ability to access and process vast amounts of data, control physical and digital assets, and make autonomous decisions, present attractive targets for malicious actors seeking to exploit vulnerabilities for personal gain or to cause disruption. One significant security concern is the potential for adversarial attacks. These attacks involve manipulating the input data or the internal workings of an AI system to induce erroneous behavior or extract sensitive information. For example, an attacker could subtly alter the data used to train an AI model, introducing biases that lead to biased decisions or creating backdoors that allow the attacker to bypass security measures. Furthermore, the interconnected nature of many agentic AI systems raises the specter of cascading failures. A security breach in one part of the system could propagate rapidly through the network, causing widespread disruptions or even physical damage. This is particularly concerning in critical infrastructure such as power grids or transportation systems, where a security breach could have catastrophic consequences. To mitigate these risks, robust cybersecurity measures are essential. This includes implementing strong authentication and authorization mechanisms, encrypting sensitive data, regularly updating software and patching vulnerabilities, and conducting thorough security audits and penetration testing to identify and address potential weaknesses. The ethical imperative addressing bias and fairness. Ethical considerations are paramount in AI development. Bias in AI decision-making is a pressing concern. AI systems can perpetuate and amplify societal biases, leading to unfair outcomes. Addressing bias requires diverse data, transparency, and ongoing monitoring. Developing fairness metrics and tools is essential for ensuring fairness. Towards responsible AI governance and transparency. The transformative potential of agentic AI is undeniable, but realizing that potential responsibly requires robust governance frameworks and a commitment to transparency. These frameworks should provide guidelines for the ethical development and deployment of AI systems, ensuring they benefit humanity and do not infringe on fundamental rights. Establishing clear lines of accountability and transparency is crucial for responsible AI. This collaborative approach ensures AI technologies benefit all of humanity. The evolving landscape of agentic AI. Agentic AI is poised for transformative advancements, driving innovation across industries. Future research will focus on creating adaptable agents that can dynamically adjust to challenges. Integration with IoT could lead to intelligent systems optimizing processes in real time. Quantum computing could enhance agentic AI, solving complex problems intractable for classical computers. Human-AI collaboration, a symbiotic partnership. The future of AI lies in fostering a symbiotic partnership between humans and machines. AI systems will augment human capabilities, providing insights and support, while humans make critical decisions. This collaboration leverages the strengths of both humans and machines. Humans excel at creativity and ethical judgment, while AI excels at processing data and identifying patterns. Together, they create more intelligent and adaptable systems. Adaptive algorithms, navigating dynamic environments. One of the key challenges in designing effective agentic AI systems is equipping them with the ability to operate effectively in dynamic and unpredictable environments. Real-world scenarios rarely unfold as neatly as theoretical models, and unforeseen circumstances, changing conditions, and unexpected events can throw even the most sophisticated AI systems off course. To address this challenge, future research will focus on developing more adaptive algorithms. These algorithms will enable agentic AI systems to learn continuously from their experiences, adjusting their strategies and behaviors in real time to maintain optimal performance even as their environment changes around them. Imagine an autonomous delivery drone navigating a crowded city. The drone's path planning algorithm must account for obstacles, weather conditions, traffic patterns, and even unexpected events like birds or other drones. An adaptive algorithm would allow the drone to learn from each encounter, adjusting its flight path and decision-making process to improve its performance over time. This adaptability will be crucial for deploying agentic AI systems in complex, real-world scenarios. Whether it's optimizing traffic flow in a bustling metropolis, managing resources in a disaster relief effort, or personalizing treatment plans for individual patients, the ability to adapt to changing circumstances will be essential for success. Self-learning models. Embracing continuous improvement. The most sophisticated agentic AI systems of the future will not be static entities frozen in time, but rather dynamic self-learning models capable of continuous improvement. These systems will constantly analyze data, identify patterns, and refine their own algorithms and decision-making processes, becoming more intelligent, efficient, and effective over time. This self-learning capability will be driven by advancements in machine learning, particularly in areas like reinforcement learning and deep learning. Reinforcement learning algorithms allow AI agents to learn through trial and error, receiving rewards for desirable outcomes and penalties for undesirable ones. This feedback loop enables the agents to optimize their behavior over time, becoming increasingly adept at achieving their goals. Deep learning algorithms, inspired by the structure of the human brain, excel at identifying complex patterns in large datasets. By feeding these algorithms vast amounts of data, we can train agentic AI systems to recognize subtle correlations, anticipate future trends, and make increasingly accurate predictions. This continuous learning and improvement process will be essential for keeping pace with the ever-increasing complexity of the world around us. As new challenges emerge, new data becomes available, and new technologies are developed, self-learning agentic AI systems will be able to adapt, evolve, and remain at the forefront of innovation. Resources and pathways for continued exploration. The field of agentic AI and analytics is ripe with opportunities for researchers, practitioners, and anyone interested in exploring the frontiers of this transformative technology. Numerous resources and pathways exist for those seeking to deepen their understanding, contribute to ongoing research, or pursue careers in this rapidly evolving field. Academic institutions around the world offer specialized programs in artificial intelligence, machine learning, and analytics, providing students with a solid foundation in the theoretical underpinnings and practical applications of agentic AI. These programs often involve cutting-edge research projects, providing students with valuable hands-on experience in developing and deploying AI systems. Professional organizations such as the Institute for Analytics and the Management Sciences, INFORMS, and the Association for the Advancement of Artificial Intelligence, ADA, offer conferences, workshops, and publications that provide insights into the latest advancements in the field. These organizations also provide networking opportunities for professionals to connect, collaborate, and share knowledge. Furthermore, numerous online resources, including open-source software libraries, online courses, and community forums, provide accessible pathways for individuals to learn about agentic AI at their own pace. These resources often feature tutorials, code examples, and case studies, allowing learners to gain practical experience with the tools and techniques used in this field. Embracing the agentic AI revolution. As we conclude this introductory exploration of agentic AI and analytics, one overarching theme emerges. We stand at the cusp of a transformative revolution in how we approach complex problems and make critical decisions. Agentic AI, with its ability to analyze vast amounts of data, learn from experience, and make autonomous decisions, has the potential to reshape industries, optimize processes, and unlock new levels of efficiency and innovation. We've journeyed from the foundational principles of analytics, exploring concepts like optimization, game theory, and stochastic processes, to the cutting-edge realm of agentic AI, delving into multi-agent systems, decentralized decision-making, and advanced algorithms like reinforcement learning and heuristic search. We've seen how agentic AI is being applied across diverse sectors, from optimizing supply chains and automating financial trading to enhancing healthcare diagnostics and revolutionizing transportation systems. The examples we've discussed, however, merely scratch the surface of what's possible. As agentic AI technology continues to evolve, driven by ongoing research and development, we can anticipate even more innovative applications emerging, addressing some of the world's most pressing challenges and creating new opportunities for progress. Shaping the future of decision-making. The transformative potential of agentic AI extends far beyond mere technological advancement. It has profound implications for the future of decision-making itself. As these systems become increasingly sophisticated, capable of processing information and making judgments at speeds and scales unimaginable to humans, we are presented with a fundamental shift in how we approach complex problems and make critical choices. This shift requires a careful balancing act. On the one hand, we must harness the power of agentic AI to enhance our decision-making capabilities, leveraging its ability to analyze vast data sets, identify patterns, and generate insights that would elude even the most astute human minds. On the other hand, we must proceed with caution, ensuring that these powerful tools are deployed responsibly, ethically, and in a manner that aligns with human values and societal goals. This means addressing the ethical considerations inherent in autonomous decision-making. We must grapple with questions of bias, fairness, and accountability, ensuring that agentic AI systems are designed and deployed in a manner that promotes equity, transparency, and human oversight. The goal is not to blindly cede control to machines, but to create a future where humans and AI work in concert, leveraging the strengths of both to achieve optimal outcomes. Researchers, practitioners, policymakers, and citizens must engage with this transformative technology. Researchers push boundaries, developing robust and ethical AI systems. Practitioners optimize processes and drive innovation. Policymakers create regulations that foster innovation and safety. Engage in dialogue about the societal implications of agentic AI. Together we can shape a future where agentic AI empowers us all.